All right, we're going to begin today with, as the students have already noted in here, our third to last speed drill. Okay, so speed drill number 48 at the bottom of page 22. Multiplication box, haven't had one of these in a little while. Got 1 minute and 45 seconds, and you may begin. All right, stop. Pencils off your desks, pens out, and exchange with the person behind you, person back, bring yours up front. Pencils off your desks, pens out, exchange with the person behind you, person back, bring yours to the front. Michael finished scant moments before Bryson. Looked at Bryson like, oh yeah, I beat you. And then Luciana's been sitting there for like 15 seconds. She'd been finished at this point to her like, oh really? And then she had to change something real quick. And Michael's like, oh yeah, it was me. Anyway, let's sign your name at the bottom as the grader. Sign your name at the bottom of the page as the grader. In pen, again, pencils are off your desks. Make sure you're listening carefully. I'm going to read each answer only once. Going across the top row, the one beginning with the 11, your answers should be 110, 66, 132, 22, 33, 88, 121, 55, 99, 44. Write the total number wrong at the end of the row. Hopefully you're writing a -0, but write the total number wrong at the end of the row. The row beginning with the 9, your answers are 90, 54, 108, 18, 27, 72, 99, 45, 81, 36. Write the total number wrong at the end of that row. Again, hopefully it's a -0. The row beginning with the 12, for some of you this was the row you did last, that's okay. 120, 72, again that was 72, 144, 24, 36, 96, 132, 60, 108, 48. The total number wrong at the end of that row. The row beginning with the 6, 60, 36, 72, 12, 18, 48, 66, 30, 54, and 24. And the bottom row, beginning with the 8, going across, the answers are 80, 48, 96, 16, 24, 64, 88, 40, 72, 32. Total number wrong at the end of that row. Now look at the end of each row, figure the total number that were missed, multiply that by 2, and subtract from 100. They are 2 points each. Pull up the score in the score blank, and also in the third to bottom blank, next to where it says speed drill 48 on the score page. Yes, sir.
Divided by what?
Total number wrong, multiply by 2, and subtract that from 100. They're 2 points each. 2 points each. Once you got to grade both places, return to the owner by passing it to the person in front of you. If you're at the front of the row, take it to the back. And owners, take a look at your, hey, I always check everything anyway, so you'll be all right. Owners, take a look at your scores. Any hundreds? Anyone perfect? All right, got a few guys perfect. How about 90-something? You got an A at least. Okay? How about 80-something? Got a B at least. All right, pass those forward if you would, please. Pass those forward if you would, please. Take your books, open to page 444 as we take a look at your homework. Page 444. Had several students out yesterday, a couple of you making up a test, and then a few people just out sick, and got everybody back today, which is nice. So those watching on video may have noticed that there were several students that didn't get called on yesterday. Well, they're back today. So we're going to do a little bit of catching up for some of those who were out yesterday. We began doing one of my favorite things in math, and what is that? Jalen?
So you have to find the letter.
Find the letter. We call it solving a, what do we call these things? They have equal signs in them. Joel? Solving equations, yes. And the key to solving an equation is to get the letter, but by the way, what do we call the letter? Because it's called the variable. Get the letter by itself. What's the key, class? Get a letter by itself. Get it all by itself. Isolate the variable if you want to sound smart, but I like to just sound like normal. So get the letter by itself. And so that's what you did as you worked numbers 2 through 20 for the even. The first several of these were solving equations. They're on page 444. Much of the work done on paper, so you have that out as well. And some of you may have been able to squeeze it in there in the book, but most of you doing it on paper where there's a little bit more space to show that work. Good, you worked here. Good. Good. 444. Said that a couple times. Should pay attention. And there we go. All right, let's take a look at these together. Starting with number 2, they gave us a really easy equation, y minus 5 equals 1. And so to get the letter by itself, we think of the equal sign like a wall that separates two sides. The 1 is not with the W, right? If someone is out in the hallway, they are not with us in this room. But who is with us in the room? Well, look around. You guys, right? You're with me in the room. So if I wanted to be by myself, I would kick you all out. Just get you all into the hallway. Get you on the other side of the wall. Fortunately, I like seeing your bright smiling faces early in the morning every day, and so I keep you around. But I got a really nasty face from Jalen now. Anyway, she's trying to get kicked. Anyway, so we want to get the W by itself. Well, what is with the W, class? A negative 5 or a minus 5. You can think of it either way, but I prefer to think of it as a negative 5. That's what's with the W. And we said to get rid of something, you always do, class, the opposite. The inverse operation, if you want to sound smart, we do the opposite. It says negative, so class, I put a positive 5. Or you could think of adding 5. But, big rule of equations. What you do to one side, you gotta do to the other. So if I add a 5 right here, put a positive 5 here, I gotta put a positive 5 here as well. The inverse property says that if you have a negative and a positive, they don't cancel each other. They don't. So all I've got now is a W on this side of the equal sign, on this side of the wall. It's by itself. Over here, I have a 1 plus 5 class, 6. And I'm done. That easy. Get the letter by itself by doing the opposite of whatever it says currently with the letter. Number 4, I've got a Z plus 35 or positive 35 equals 21. Well, what do I got to do to get the Z by itself? Kirsten?
Change the 35 into a negative?
Well, not change it into a negative, but put a negative 35 with it. Right? It's got to have a positive, so put a negative because that negative is going to cancel with the positive. But what I do to one side,
You have to do the other.
I'm going to strategically write the negative 35 above the positive 21 to make it easier to subtract and keep the sign of the greater. Z is by itself over here. What would we have, Kirsten?
14.
But keep the sign of the greater?
Negative 14.
Negative 14 should be our answer there. Look at number 6. We got an A positive 5 is equal to negative 9. Jalen, what do we have to do to get the letter by itself? Yeah?
The negative 5
On
both sides.
both sides. Here it cancels. A is by itself. Notice how I'm keeping the equal sign, that wall neatly lined up. And then on the other side we get?
5 and a 4.
Well, remember the signs are the same, so we got to add and keep the sign.
Negative 4. No. Negative 14.
Negative 14, there we go. Number 8, we have an n minus 1/3 is equal to 1/4. What do I have to do to get the n by itself, Griffin?
Put positive 1/3 on it, and that cancels out, and you put it by the 1/4.
And here, wait, a 4th plus a 3rd. Class, can we add those?
No.
Not the way they're written. We have to get a common denominator. So the n is by itself at least, but over here we got a little bit more work to do. How many 12ths, class, is a 4th?
3.
And how many 12ths is a 3rd?
4.
So when we add, Griffin, we get
7 12.
7 12ths. Any questions on the first 4? 2, 4, 6, 8. Any questions on 2, 4, 6, 8? Ben, Kirsten, particularly since you were both out yesterday, and then Michael, Jalen, you missed a lot of the lesson yesterday. They came in time for the back half. Any questions on these first 4 problems? Anyone perfect on the first 4 problems? Several of you, good. Let's take a look at number 10, and this one's got a little bit more work involved. The only difference between number 10 and all the other ones we've worked so far is it's not just one nice, easy number over here. That's okay. We can make it a nice, easy number over here because Corey, negative 3 up against another negative 3 gives me what?
Positive 9.
Positive 9 when we multiply. And so if I'll just take the time to simplify this other side first, now it becomes like all the other ones. Now, Ben, to get the letter by itself, I just have to get rid of the...
4.
Well, it's not a 4, it's a...
3.
No, this is not a 4, Ben. It is a...
Positive 4.
That's a positive? It's a negative 4, right? And that's important because we have to pay attention to whether it's positive or negative, because that tells me what to do to get rid of it. Because it is a negative 4, I can get rid of it by putting a positive 4. But I can't just do that on one side. I got to do it on both sides. So I'm going to put a positive 4 on the other side as well. Then what happens to the negative 4 and positive 4? They get crossed out, they get canceled away. I keep the B, keep that equal sign, that wall lined up. And then on the other side, what will we get for our answer, Ben?
12.
Who cares from that plus 4?
13.
13. There we go. B equals 13, our answer there on number 10. Number 12, I'm lazy. I don't want to copy this down as written because I can take care of simplifying that right-hand side in my head, and all of you can as well. So I'm not going to write down m plus 16 equals 5 times 3, because I'm going to write down 15. Make sure we're keeping a hold of things so we're not being a distraction. We're going to multiply the 3 times 5, get that 15. Then we need to get the letter by itself. Michael, what do we do to get m by itself?
We add the inverse.
Which is?
Negative 16.
We're going to put a negative 16 on both sides. It cancels here to get m is equal to?
1. I mean, negative 1.
Negative 1, good, because we keep the sign of the greater. Excellent. And then number 14. Again, I've got x minus 8, but I'm not going to write down 7 times negative 11. Instead, Joel, we can just write
Negative 77.
negative 77. Simplify in your head what's easy to simplify in your head. You know what I'm saying? Be lazy a little bit. And now, to get the x by itself, what do I got to do? Bryson?
You got to at the inverse or positive 8
On
the other side.
both sides. Good. Put the positive 8 here. It cancels. I get x equals what here? Elaine?
Negative 69.
Negative 69. Anyone perfect on 2 through 14? The even. You went through all the equations perfect. Okay, as the equations got just a little bit more tricky, not much more tricky, any questions then from those who were out yesterday? Any questions from those who were here yesterday and for whatever reason maybe had a little bit of struggle? Any questions at all in those? Then we come to number 16, and we have not gone over problems like 16 yet. We're going to look at it more today. But just as a preview, let's take a look at it. Luciana, would you read 16 for us?
9 more than the number is 36. What is the number?
9 more than a number is 36. What is the number? Well, I don't know what the number is, right? But if you don't know what the number is, we can represent it with a variable. I could call it X if I want to be boring. Or Luciana could call it L, or Elaine could call it E, or Corey could call it C, or whatever, right? We could Q, because Q never gets any love. Whatever, okay? We could name it whatever letter we want. What we want to do, it says to write an equation. Well, class, with your finger, would you cover up the words is 36? With your finger on number 16, would you cover up the words is 36? And let's read the beginning of the problem together up to where our finger's covering. 9 more than a number. Well, we're going to let Luciana pick. What letter do you want to use?
E.
E. All right, so E is our letter here. 9 more than, instead of a number, class, because we don't know it, it could be anything. We're going to use a variable. We're going to use E. 9 more than E. Well, class, how do I write 9 more than E?
E plus 9.
E plus 9. This goes back to what we already know how to do. The difference is, instead of telling us what letter to use, it's just going to say a number. Does that make sense? You get to pick whatever letter you want. All of you might have different letters, and that's okay. But then we covered up 2 things, class. We covered up is 36. At the top of this page, would you write is means equals? Is means equals. In fact, in general, forgive me for bringing a little English class into this, verbs mean equals, especially linking verbs. But in math, as we go through the next 6 years of, or I guess, correction, we're almost done with 7th grade. As you go through the next 5 years of math, whenever you see a verb, again, a lot of times a linking verb, it's your equal sign. Have you noticed, how do you mark a verb in English class?
2 lines.
You put an equal sign under it, don't you?
Huh.
Because the verb is your equal sign. So as we go through this, especially with linking verbs, in fact, you even do this, right? When you talk about predicate nominatives, like Bryson is the captain of his team. Bryson is captain. Bryson equals captain. Hey, it's a predicate nominative. You remember doing that? So when it says is 36, class, that means equals 36. And this is how we can translate word problems into an equation. Now, it's not like you necessarily needed the equation to solve, because it was really easy, but they wanted you to set up an equation, and this is how we would do it. Questions on that? We'll come back to this a little bit more later. Now we got to solve the equation. And Elaine, it's named E, so we'll go to you. What do we do to solve this equation?
Add the inverse, which is negative 9 to both sides. Then 36 minus 9 is 27. So E equals 27.
Good. We cancel away the positive and negative 9 and get that 27 there. Any questions on 16? Any questions on 16? How many figured out, with or without an equation? The answer was 27. I mean, it wasn't a hard thing to solve. But again, we're going to start practicing translating into algebra and make your life easier in the days ahead. Let's take a look very quickly at the evens in the blue section. Now, practicing with inverse properties. Number 18, what do you have to add to 15 to get a 0? Griffin?
Negative 15.
Negative 15. Number 20, what would we have to subtract 56 from to get 0? Jalen? 56. What would we have to multiply? Ooh, here's a tricky one. What would we have to multiply negative 89 by to get 1, Joel?
1 over 89.
Really close. Bryson?
Negative 1 over 89.
1 over negative 89, or negative 1 over 89. There we go, good. Because we need to cancel the negative also. So we got the reciprocal 189th to cancel. We just need to remember the negative as well to cancel with the other negative they gave us. And number 24, let's go back to Joel. What would we need to multiply 24 by to get a 1? Or on number 24, what would we need to multiply 3/11ths by to get a 1? 11 over 3, or 11 thirds. Questions on those inverse property things? All right, how many got all those correct? Questions at all? All right, flip back if you would to page 443. Flip back now to page 443. And I want you to do numbers 19 to 24 on page 443 as we finish out the page. We got most of these problems worked yesterday. Had to stop at number 18 for sake of time. So let's finish out the page 19 to 24 as we get rolling today. And the key, class, is to get the letter by itself. Thank you, Bryson. Class, the key is to get the letter
By itself.
There we go. Making Bryson sing a solo here. We don't want to do that in chapel, do we?
Mm.
No. I say if Bryson singing a solo, the mighty power of God wouldn't seem quite so mighty today. So we need all y'all singing. All y'all singing. Make it sound extra mighty.
That's crazy.
Poor Bryson. We love you, Bryson. We just also love picking on you, so.
They should not agree or whenever you're gone.
Mm.
What?
Whenever you're gone, ain't
Oh,
appeared.
We were picking. Yeah. Everyone knows.
I take it you watched the video then?
Oh, that's messed up.
Elaine's got it. Oh, you finished as well? Oh, well, good job. Michael's finished. Jalen's finished. All right, finish up, Bryson. Work the mighty equations of Mr. Nadaski.
More like a bank now.
Well, you know, I don't get any credit around here. Did you drop something again?
That's just so weird.
Remember chess club we did? And you run the track.
Yeah, cross country.
Yeah.
I did both.
Same.
Oh, not entirely. When you get a nice even surface to run on, and it's boring view. Save the music for chapel. Yes, sir. We're about to look at it. Let's take a look at these together. Number 19, really straightforward, except you have to know what sign is in front of the 3. Because they don't have a sign in front of it, but if you don't have a sign class, it's an understood positive. So therefore, to get rid of the 3, you have to put a
Negative.
and what you do on one side.
Yeah.
What happens with the positive negative 3 class?
Cancel.
So leave me with just
Zero.
S. And then we have our equal sign on the other side, we get
Three.
3. How many have that answer for number 19? Number 20, I gotta simplify a little bit. On the left-hand side this time, what should I, based on order of operations, what should I do first? Ben?
Well, add
The 3 plus 4 to get?
7,
And then what do I do with the 2?
multiply
By the 7 to get
14.
14. Again, I want to do all that in my head because I'm too lazy to write that on the board. So we get 14 equals our positive 9. Now again, which number do I have to get rid of here, Michael?
Negative 14. I mean, yeah, the 14.
Is the 14 with the R?
No.
No.
No. And this is where students get themselves in trouble, is sometimes the letter shows up on the other side and we're not used to that. And so we're fixated on getting rid of whatever number's over here. But we have to get rid of whatever's with the R because the goal is to get the letter by itself. The 14's not with the R, it's on the other side of the wall. In this case, it's on that side of the classroom. It fell. All right, so anyway, but the 14's not the problem, it's the 9 that's the problem. How do I get rid of the 9, Michael?
You change the 9 to a negative 9.
We don't change it to a negative, you put a negative 9 with it. And what I put on one side, so over here I gotta put a negative 9 as well. And what am I gonna get for my answer, Michael?
5. R equals 5.
5 equals R. Or if it really bothers you, it's an equation. They're equal, so you can switch them around if you want to. R equals 5, 5 equals R. Kind of like Bryson is captain, captain is Bryson. You can flip them around, right? We do that in English class. We can do it in math class.
No.
Anyway, like, no, stop talking about English. Number 21, what do we have to do on both sides, Kirsten? Add a positive 2 to both sides to get?
Positive 7.
V equals positive 7. Number 22, Ben, you asked about the fractions. One of the fractions I have to get rid of. Which fraction is the problem, Ben?
1/2.
The 1/2, because it's with the M, right? It's like, I don't know, y'all ever watch Foghorn Leghorn? Get out of here, kid, you're bothering me. Anyway, we gotta get rid of the 1/2. It's bothering the M, right? M's like, get out of here. So we gotta get rid of the 1/2. How do we get rid of a 1/2, Ben?
Make it a negative?
Well, not make it a negative, put a negative. Put a negative 1/2 right there with it. Because the positive negative 1/2 will cancel. But what I did on one side, so I gotta put a negative 1/2 here. Well, I can't subtract those the way they're written. They don't yet have class A common denominator. But what is the common denominator, anyone? 8. So I can change this to how many 8s, class? 4 8s. Multiply top and bottom by 4. So now then, now we can subtract. 5 8s minus 4 8s would give us 1 8. And that's how we work a problem like number 22. How many had 1 8 for number 22? Number 23. Again, it looks like there's this ugly fraction, but it's really not so much a fraction as much as it's what kind of problem over there, Joel? It's a division problem. But instead of writing 108 divided by 12 like this, they wrote it the better way in algebra that we use, and that's 108 over 12. Well, we know what 108 divided by 12 is, class?
9.
It's 9. So really we end up with a y plus 6 equals 9. But don't view it as a fraction, view it as a division problem. Does that make sense? And now to get the y by itself, what do we need to do, Elaine?
We need to put a negative 6 on both sides
To get,
to get 0 and 3.
well, y equals 3, not 0, y. The y is still there, y equals 3. Number 24. Now here we got a legitimate fraction, and the fraction's up against a 21. Well, what does it mean if something is up against something else in algebra, class? So we're multiplying the 3/7 by 21. If we wanted to look at it this way, we could. I'm not going to use the x, I'll use the raised dot, but it would help if we put the 21 class over 1. Now do we see what we can do with this fraction? Class, we can do a little canceling, right? The 7 and 21 are going to cancel, Griffin, to give me,
3.
and technically
1.
1. Well, that means it's really 3 times 3 now, isn't it? And 3 times 3, class, gives us 9. So really, this is 1 plus w equals 9. How do I finish it out now, Griffin?
Negative 1 under the 1, and you have to do the same to the 9, and that will become 8, so it's w equals 8.
There we go. Cancel away, get w equals 8. Anyone perfect on all 6 of those? All right, any questions on it? Does that make a little bit more sense seeing it now? Okay, good. Any questions? All right. Let's take a look at page 441. Flip back to page 441, if you would, please. And let's talk a little bit more about these word problems. Again, number 16 from the homework was one of these. We haven't even talked about it yet, so I kind of gave you a little bit of a preview. Let's look at it a little bit more in depth here on page 441. Here's a yellow box where it says steps to solving algebraic word problems. Read step number 1 and everything under it for us, if you would, Michael.
Recall that an equation is a mathematical statement.
Right here where it says number 1, go ahead and read number 1 and everything under it.
Read the word problem for understanding. Identify and know whose value must be found. Identify what information has been given. Represent the unknown with a variable.
All right, mark that last thing he said. Represent the unknown with a variable. Okay, you read it and you're like, okay, this is the thing I don't know. Represent it with a variable. Make a letter. Whatever you don't know, make it some letter, and you got 26 to choose from. Okay? Then number 2, read number 2 and everything under it. Kirsten.
Write and solve. Write the equation. Look for a statement of equality within the problem. The key word is usually translates mathematically to equal sign. Writing an equal sign above may help identify the two expressions that make up the equation. Translate key words and phrases
Algebraically. That's a good word.
Use the assigned variable from step 1 to represent the unknown within the equation. Solve the equation.
All right, right next to that second part where it talks about is meaning equals, write it again. Is means equals. Is means equals. And what you read there right above where it said solve the equation, translate key words. Remember in the homework problem it said 9 more than a number. Okay, so whatever our number is, I don't know, E, we have to have 9 more than that. plus 9, E plus 9. So think through what product or sum, more than, less than, ratio, all those different words that we talked about earlier, making sure we got those. And then, of course, to finish it out, go ahead and read point 3 and everything under it, Jalen.
State and check. State the answer to the word problem. Check the answer mathematically using substitution, mentally by considering its reasonableness.
There we go. Does this answer make sense is usually a good way to check. Because usually, if you mess it up, you're going to mess up by numbers like that. Doesn't even make sense. So checking that as well. Turn the page now. Let's look at a couple of example problems. In the blue shaded box, read letter A's problem for us, if you would. Corey?
7 increased by a number equals negative 16. What is the number?
All right, so the thing they want us to find, class, they want us to find some number. We don't know what it is. Corey, instead of having a number, we're going to represent it with a letter. What letter would you like to use?
C.
C. So in other words, instead of 7 increased by a number, class, we could say 7 increased by C equals negative 16. Well, what does increased by mean? We need to add, right? So if you add 7 to a number or to C, it equals negative 16. Do you see where they got their equation from? 7 plus, now they didn't say go C, they said X. 7 plus X equals negative 16. Do we see what they did there? 7 increased by or plus some number, I don't know, X, C, equals negative 16. Now, to get the X by itself, notice what they put on both sides, class. Negative 7, and that gave them their answer. X equals negative 23. Now think reasonably about this. We have 7, and we're increasing it by some number, which makes it goes bigger, right? And yet the answer is negative 16. That can only happen if we increase it by some negative value. Does it make sense that our answer would be a negative 23 then? And that's how we think reasonably about it. Does that make sense? Yeah, it makes sense. Questions on the first part of the example problem. Read the second part for us, if you would, Bryson.
9 less than a number is negative 8. What is the number?
Again, the thing they want us to find, class, they want us to find some number. So we're going to represent that number with a letter. You're going to choose?
Q.
Q. All right, so they, of course, chose N this time, but we're going to choose Q. 9 less than Q is negative 8. Well, what does less than mean, class?
Subtract.
Subtract. But the than also tells me to
Flip it.
flip it. So 9 less than Q, class,
Q minus 9.
which is fun because Q, if you don't put a little tail on it, looks like a 9. So Q minus 9. 9 less than Q, and then it says is negative 8. Well, class, is means equals. So when it says is negative 8 means, class,
Equals negative 8.
equals negative 8. And to solve, we got to get rid of the negative 9 by putting what on both sides?
Positive 9.
Positive 9. And when we do, we get the same answer they got. Q, in our case, they had N. Q equals 1. Does it make sense that if you decrease or you take away 9 from a 1, you'll get negative 8? It makes sense. There's our answer. Questions on those? Turn the page. Page 444. And let's look at the top of the page. Read number 25 for us now, if you would. Not Corey. Griffin, read number 25 for us.
5 more than a number is 97. What is the number?
At your seats, I want you to write the equation for that sentence. 5 more than a number is 97. At your seats, you write an equation. Griffin, once you're done writing it, tell us what you wrote.
I wrote B plus 5 equals 97.
How many had, now you could have had a different letter here, but you had some letter plus 5 equals 97. Anyone have 5 plus a letter equals 97? Now you're not wrong because addition is commutative, but remember the than means to flip it. So the better way to write it would be letter plus 5. Doesn't really matter though, because to solve now, class, what do I got to put on both sides? A negative 5. And we can do this in our heads pretty easily. B, or whatever your letter is, class, equals 92. Now, questions on this first one? Your first time trying to figure out the equation on your own since I taught it. Any questions? Say, how did you figure that out? All right, number 26. Read that for us if you would, Joel.
72 less than a number is 28. What is the number?
At your seats, write this as an equation as well. 72 less than a number is 28. Write the equation. Okay, you two, stop making eyes at each other. Groups up front. I wasn't the one looking weird at people. So like, I don't know.
Come on.
Always making.
All right.
You don't.
So, Joel, what is your equation? Hush.
L minus 72 equals 28.
How many had letter, whatever it was, minus 72 equals 28? Did anyone have 72 minus letter equals 28? Okay, in this case, that would be wrong, wouldn't it? Because subtraction's not commutative, so you can't get away with the not flip when it's a less than. And so, to solve this problem, what would we need to do, Joel?
We would need to add the inverse and get positive 72
On
both sides.
good.
And the answer L equals 100.
L equals 100. Questions on number 26. Questions on 26. Now, so far, every one we've done has been blah, 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 a number, blah, 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 a number. And we're always just solving for a number. And then on number 27, they ain't do that no more. Look at number 27. Read that for us, if you would, Luciana.
A new bottle of nail polish from an online retailer costs $8. The online cost is $3.02 more expensive than the same nail polish at the local value store. What is the cost of the nail polish at the value store?
Ah, okay. So what is it we need to find? We're not trying to find some number. Luciana, what does it say we're trying to figure out?
So subtract $3.02.
No, we're not, no. What are we trying to figure out? Not what do we do, but what are we trying to find? What do we not know that we need to know?
Oh, the cost of nail polish at the value store.
The value store price, right? So we could buy it online or we could buy it at value store. We know how much it is online. Classic tells us it's $8, but we don't know how much it is at the value store. So we need to represent the value store price with some letters. Everyone understand that? We might choose V for value store. That might be, help us a little bit. So if we just choose V for the value store, look at how it compares those two things together. Again, we're not trying to figure out online. We know online costs how much, class? $8. So if we want to write this down, online, $8. Value, I don't know, V, okay? But what does it tell me about these two compared to each other? Let me say that again. How does it compare them to each other? Read that sentence for us, Luciana, the second sentence.
The online cost is $3.02 more expensive than the same nail polish at the local value store.
All right. Follow along with me here, class. The online cost, do we know what that is? What is it?
$3.
It's 8, okay? That means equals $3.02 more expensive than. Oh, so what should I do? Add $3.02 to something. $3.02 more expensive than the same nail polish at the local value store. At your seats. See if you can take the hints I gave you and make an equation out of it. The online cost, we know that's $8, is $3.02 more than the nail polish at the local value store. Jalen, what's your equation that you wrote here?
I had $8 plus $3.02
All right. So it said the online price, that's $8, but then right after it said the online price, it said the online cost is. So what should come right after the 8? That's where we're going to put the equal sign. And it's not $3.02 more than online, it's $3.02 more than value store. So we're going to add the 302 to the value store. Does that make sense? Or, since it said than, technically we could say V plus 302. Did anyone have one of these? All right, again, this was a lot more tricky than the last ones. Any questions of this? Does that make sense now? Others who may have missed it, does it make sense now? The online cost, we know that's 8, is $3.02 more than, so flip and add, value store. I don't know what that is, that's just V. All right, what do we need to do to solve now? Let's go back to Luciana.
rate, we'll add the inverse, so add negative $3.02.
Good.
And do the same for the other side.
It might help if I wrote this as $8 with some decimals here, wouldn't it? Because I'm going to have to do some subtraction here. What do we get, anyone, when we subtract $3.02 from the $8 online price? What do we get, Ben?
$4.98.
Good. How many had $4.98 there? All right, so value store, it's cheap. You buy it online, which usually online's cheaper, right? That's what I have found, at least. You know, it's too expensive in store. I'll buy it online for cheaper. Doesn't always work that way, I guess. Questions on 27? Yes, sir.
Well, you did it. My thing is, couldn't you just subtract 8 minus 302?
We did. Yeah, we did.
Instead of doing all the other work and just put a V.
Well, but remember, this is 7th grade. All I'm doing is starting to lay the foundation. The problems are going to get bigger and bigger and bigger in the years ahead. So I'm starting with stupid, easy problems that you can easily figure out on your own, but I'm teaching you how to make them equations so that when you get to the harder problems that you are not going to be able to figure out in your head, you already know how to make equations out of them. So I'm laying a foundation here for you. So even though, yes, I know y'all could be like, I just know how to subtract 302. Why do I got to go through that? Because we're laying a foundation for what's coming in pre-algebra, algebra 1, algebra 2. Does that make sense? So yeah, stick with the process here. Number 28, read that one for us here. And this sounds like stuff y'all did recently with your STEM project. Read this one for us, Elaine.
An economy-sized package of paper towels costs 82 cents more at store A than at store B. If the paper towels cost $5.97 at store A, how much do they cost at store B?
All right, now notice there's two things that they're comparing here, class. The prices at store A and at store B. But only one of these is actually unknown, right? I know one of the stores. Which one do I already know, class?
Store B.
Store A. Look at the last sentence. It says, if the paper towels cost $5.97 at store A. So store A is not the question. I know store A. What I don't know is store B. Right? It asks, how much do they cost at store B? So since we don't know, we're going to represent it, class, with a letter, a variable. What letter might we pick for store B, class? B. Makes a lot of logical sense. Now again, if you want to be boring, you could just always use X. But we'll throw a little creativity in here. We'll mix it up a little bit. What does it say when it compares these two stores' prices to each other, though, Elaine?
I don't know.
Well, read the problem again for us and see if you find the comparison between the two shops.
An economy-sized package of paper towels costs 82 cents more at store A than at store B. 82 cents?
82 cents more at store
A
than at store
B.
B. So store B is actually, is it more expensive or is it cheaper?
Cheaper?
Store B is actually the cheaper store, isn't it? They cost 82 cents more at A than at B. A costs 82 cents more than B. Do you see it? Maybe write that off to the side. A costs 82 or 0.82 more than B. Well, do we know store A, class? Yeah, what is it?
$5.92.
And you see that the word costs is my verb. They don't use the word is this time, but they do have a verb. And class, the verb is my equal sign. And when it saes 82 cents more than B, class, we could write that.
0.82 plus B plus 0.2.
Well, the than would flip it generally, right? No, it's not wrong if you don't because it's addition, but B plus 0.82. Now, to solve for B, class, we simply
Do the math.
do the math. By doing what?
Inverse
Negative 0.82 on both sides. And what do we get for store B, class?
$5.15.
$5.15. Questions on this one? This time they didn't give us an is. They gave us a different verb, but we could still extrapolate it means equals when we see that verb. Flip over to page 448. Flip over to page 448. And take a look at the review section there. Take just a few minutes. We'll close out the hour by working just a few more equations. Do the review 26 to 31 on page 448. Once you finish, Put your pencil down, stand next to your desk. The review section, Ben. The review, 26 to 31. Woo! Got a Michael, Corey, Joel, and a flurry. Joel's foot was actually out first. He didn't stand up next. All right, there's Jalen. Good. And don't fall down. And Luciana. Eddie Lane. Bryson. Hey, Corey, get off his desk. All right, have a seat. And Michael was first by a hair and then another hair. Number 26, you got to put a -3 on both sides. What do you get, Michael?
14.
X equals 14. Number 27, got to put a +1 on both sides. You get?
P equals 3.
P equals 3. Number 28, got to put a -5 on both sides. You get?
C equals -11.
C equals -11. Going across the bottom row, we needed to simplify that left-hand side first, Michael, to get?
Wait, you want the answer?
No, I'm not asking for that. I said you got to simplify the left-hand side first to get
-6.
the left-hand, or excuse me, the right-hand side, excuse me.
14, 15, -15.
-15. And then you got to put a +6 on both sides to get the W by itself, and you get for your answer,
-9.
W equals -9. Number 30, we got to simplify that right-hand side first to get?
Y equals +7.
We got to simplify the right-hand side first to get
5.
5. Then we'll put a +2 on both sides to get for our answer,
Y equals +7.
Y equals +7. For the last one, we had to simplify the right-hand side first to get
10.
10. Then we had to put a -15 on both sides to get M equals
-5.
-5. Anyone else perfect, though not quite as fast as Michael? Any questions on any of those? You say, I did not get that answer for number whatever. Any of you say, I missed this one. Can you talk through it or show it on the board? Do we feel pretty good about basic equations? And obviously, we'll be working more on the word problems and translation and stuff like that in the days ahead. Your homework for the weekend. Homework for the weekend is to do page 444. Page 444. Do numbers 1 through 25, the odd. Page 444. Do numbers 1 through 25, the odd numbered problems. Take a look at that when we come back after the weekend. Have a wonderful rest of your day. When the bell rings, you'll be dismissed.